So this video is on chapter 8, composition and structure of atmosphere. Now, what do we mean by the word atmosphere? The atmosphere surrounds us wherever we go, and it is necessary for our survival. It has layers of gases surrounding the earth. While it may just look one vast blue sky when we look up in the sky, but there's a lot that goes there. Then atmosphere is divided into 5 layers, about which we will read as we go forward. So basically it is essential to the survival of all organisms because it contains life-giving gases like oxygen for humans and animals and carbon dioxide for plants. So the air that we need has no color, it has no smell. It can only be felt when the wind blows. And 99% of the total mass of the atmosphere is confined to the height of 32 km from Earth's surface, which means the first and little bit of the second layer of atmosphere falls into this 32 km range. Again, about which we will read in detail as we go forward. Alright, so that was a little introductory part. Now let's read about the first topic of this chapter. Composition of the atmosphere. Meaning, what is our atmosphere made of? If you look at this table, you can see the different gases we have in our atmosphere. Always remember, nitrogen, oxygen and argon are the 3 major constituents of Earth's atmosphere. You can remember it as NOAA, N-O-A. Pause the video and take a look at their respective percentages. Now here it says carbon dioxide and water vapor are found only up to 90 km from the surface of the Earth. Let me just pull up the 5 different layers of the atmosphere. Here's the pic, and you can see the first layer, which is closest to the Earth's surface, is troposphere, which exists up to 10 km from the surface of the Earth. After that we have stratosphere, then mesosphere, after that thermosphere, and finally exosphere. So here when it says carbon dioxide and water vapor are found only up to 90 km from the surface of the Earth, it means that carbon dioxide and water vapor exist till the initial boundary of thermosphere. I hope this part is clear now. Now let's read about this topic, gases. Carbon dioxide is an important gas. Remember this point, I'll get back to this. It is transparent for the incoming sun rays, but it is opaque to the outgoing terrestrial radiation. Alright, let me just explain this line, what I just said. Now you must be aware of this phenomena that differential heating of land and water is the reason behind rainfall and precipitation. Now having said that, we now clearly know that Earth's surface does gets heated up due to sun rays. And because Earth's surface heats up due to the incoming sun rays and that heat has to go somewhere, it is because of carbon dioxide, the heat is trapped within the Earth's atmosphere. This is what is causing climate change. Now you must have heard about greenhouse gases. They are methane, nitrous oxide, sulfur dioxide, ozone, carbon dioxide. So these are a bunch of gases in the atmosphere that blocks the Earth's radiation from going out in the space. Now these greenhouse gases trap the heat within the Earth's atmosphere and makes the Earth warmer. Now the interesting part to note is that the volume of other gases is constant, but the volume of carbon dioxide has been rising in the past few decades, mainly because of the burning of fossil fuels. Since the Industrial Revolution, that is from the mid-18th century, the amount of carbon dioxide has increased. Machines on daily basis are using fossil fuels like diesel, petrol, and that's emitting more and more carbon in the atmosphere, which is increasing the overall carbon content. Now, ozone is another important component of the atmosphere that is found between 10 and 15 km above the Earth's surface. Basically, it's located in the stratosphere. What ozone layer does is, it acts as a filter and absorbs the ultraviolet rays that comes from the sun. So UV rays are very harmful. If taken in excess, it can cause sunburn, skin cancer, etc. In a nutshell, they are harmful rays. Now ozone layer is protecting the UV rays from coming directly, basically it's filtering it. But this layer is depleting. It is purely due to man-made activities. Ozone layer depletion is one of the most serious problems faced by our planet Earth. Now we will read about this topic, water vapor. So basically water vapor is the amount of moisture that is present in the atmosphere. When we think of water, it is in liquid state. With vapor, it becomes a gas. So water vapor means liquid in gaseous state. So as I said, the amount of moisture that is present in the atmosphere is called water vapor. Similarly, the amount of water vapor present in the atmosphere is called humidity. And if I were to ask you in India which place is more humid, that would be coastal areas. You go to Goa, Chennai, any coastal place, it's humid because there's a lot of water vapor in the air due to the sea in front of you. And it's not the same case everywhere on Earth. The point that I'm trying to make is that water vapor decreases from equator towards the poles. So equatorial region is known for warm as well as wet temperature because direct sun rays hit only at the equator. Therefore, evaporation is high in this region. This is what increases the water vapor level in the atmosphere. Now, as you go towards the pole area, you will not find moisture. No moisture means no water vapor and no humidity. That's why when you go to a cold region, your skin will be dry and your lips may crack due to dryness. So this is what is water vapor. Now the role of water vapor is to absorb parts of the sun rays and not make the earth's surface too much warm. Likewise, it also blocks some heat of the sun rays and it does not allow it to escape out of the atmosphere. Because we don't want the entire heat of the earth to escape. Without the sun's heat, we would have frozen to death. So we need heat but not too much. And it's the water vapor that sets the right temperature for us to live. It acts like a blanket on the earth, which doesn't make the earth too cold nor too hot. And this line over here is absolutely true. Water vapor also contributes to the stability and instability in the air. Let me just explain this in a simple and straightforward way. The amount of water vapor in the atmosphere exists in direct relation to the temperature. In other words, higher the temperature, higher will be the water vapor content in the atmosphere. Just like how water vapor decreases as we go away from the equator towards the poles, similarly with increase or decrease in temperature, water vapor also increases and decreases. Now let's assume that I increase the temperature on Earth. In a more funny or relatable sense, I push the Earth a little closer to the sun. That would increase the temperature reasonably. Now more water will evaporate from oceans, right? Which means evaporation process creates water vapor. Now imagine this. When something else causes an increase in temperature, I'm talking about extra carbon dioxide from burning of fossil fuels. So you see here the trigger has changed. Now instead of me pushing the Earth closer to the sun, increase in carbon dioxide in the atmosphere is causing the temperature to rise. Now that the trigger has changed, but the mechanism remains the same. That is due to increase in temperature, more water evaporates. When more water vapor evaporates, more vapor is formed in the atmosphere. An increase in water vapor causes humidity. When there is humidity, we feel warm. Likewise, the air in humid region is warm. And the warm air rises. And that's how it comes in contact with the cool air. When warm air comes in contact with the cool air, turbulence, rainfall and precipitation occurs. So I hope you see the chain effect and you're understanding how water vapor contributes to the stability and instability in the air. I hope you're comprehending as to what I'm saying so far. Now let's talk about dust particles. So far we saw that there is tons of water vapor in the atmosphere. But I want you to know that atmosphere has a sufficient capacity to keep small solid particles. Now what are these particles? These are dust particles that originate from sea salts, fine soil, smoke from incomplete burning, ash pollen, dust and disintegrated particles of meteors. Since dust particles are fairly heavier than water vapor, therefore they are generally found in the lower layer of the atmosphere, which are troposphere and stratosphere. Now it is the air movement that takes these dust particles to a greater height and a longer distance. Now I want you to remember this point. The higher concentration of dust particles is found in subtropical and temperate regions due to dry winds. I'll show you subtropical and temperate regions on this world map. So here the winds are dry. Remember moments back we read that water vapor decreases as we go away from the equator towards the poles? That means at equatorial region, the moisture content in the atmosphere does not allow the dust particles to rise. But then as we go away from the equatorial region, moisture content in the atmosphere decreases and dry wind carries the dust particles. And as we go further away at poles area, I'm talking about North Pole and South Pole, there you will hardly find any dust particle. You will mostly see ice crystals. I don't know if that can be called as dust particle. Another important point is that dust particles are a major component behind cloud formation. Now if you see, there is water around us all the time in the form of tiny gas particles, which is also known as water vapor. Then there are also tiny dust particles floating around in the air. Now if you look closely at a black background, you can see the dust particles. So the combination of this water vapor and dust particles together forms a cloud. Obviously you must have heard that cloud is a result of condensation, where the water vapor turns into visible water droplets. But then if there isn't anything to hold them up in the air, how will a cloud form? Otherwise droplets will fall and it will simply rain. So to hold this condensed water droplet, floating dust particles come into picture. These are called aerosols. These aerosols attract the condensed water droplets, and large combination of these forms a cloud. So that's the role of dust particles. Now let's get to know quickly about different layers of the atmosphere. So this is a picture of different layers of the atmosphere. From lowermost layer to the outermost layer, overall there are 5 layers. Remember this order. Now these layers have different density and temperature. Now density is highest near the surface of the earth because of the gravitational pull of the earth. And as we go higher, the density decreases. Now coming to the temperature part, the lowest layer, that is the troposphere, is hotter because it's nearer to the earth's surface. So heat from the earth warms up the air of this layer. As the height increases, the number of air molecules decreases, and that's how temperature decreases. And this continues till the end of mesosphere. Now this place is also called as mesopause. This is the coldest part of Earth's atmosphere. Temperature falls up to minus 90 degrees Celsius. Now after mesosphere, we have thermosphere. By the word thermo, you can relate the word thermal, and which means heat. Here the temperature goes up to 500 to 2000 degrees Celsius. Now after this, we have exosphere. It is also the first layer to come into contact and protect the Earth from meteors, asteroids, comets. Basically, after this layer, space starts. The temperature here varies from 0 to over 1700 degrees Celsius. That means it is colder at night and much hotter during day. And I also remember watching some NASA astronauts interview where he said that when an astronaut goes on a spacewalk, that spacesuit they are wearing, it is like the mini spaceship. It protects them from the heat of sun, and he said something which I will always remember. He said when they face the side where the sun is, that side is illuminated by the sun. As a result, that front part of the suit is so much hot and the back side of the suit is freezing cold. I hope you're getting what I'm saying. Of course, the spacesuit has the temperature control mechanism which keeps the astronauts safe, but I hope you're getting the relevance of the extreme sides of the atmosphere. I'm going to make a separate video on different layers of the atmosphere. I mean, right now I just explained you the entire structure of the atmosphere in a simple and easy manner. But then I intend to make a separate video for those of you who just wants to understand the structure of the atmosphere without going through this entire video. So I hope you found this video useful. As usual, thanks for watching, and I'll see you in the next one.